Good morning, this is Dr. Turner with Integrated Math 3. Today we're going to be looking at 8.4. 8.4 is looking at how to solve the area of a triangle. Now, of course, we know how to find the area of a triangle if we have a base and a height. Our area formula that we've been using since middle school is 1/2 base times height. However, if we don't know the height, we can solve for the height by using trigonometry, and that's our goal for today. So here's a very well constructed triangle with a base and a height drawn. Again, the idea is if I knew that base, but I didn't know the height, how could I solve for that? Well, if I don't know the height, but I did know the base down here, then in theory, I could use substitution to solve for that missing side. And to do that, I'm going to need the hypotenuse, which I'm going to label A. In relating the height, h, to the hypotenuse, which I'm calling A, that relationship in terms of trig is sine. Sine is equal to the opposite side over the hypotenuse, so h over A. And then, getting h by itself, we have A times sine theta. Now this is again assuming that I had that first side, I know the base, but I don't know the height of the triangle. But using this now, I can substitute A sine theta for h, and now my formula becomes 1/2, and rearranging for alphabetically, AB times sine of theta. So this is an area formula that we can use that doesn't require us to have the height of the triangle. What it does require us to have, however, are two sides and the angle that is in between them. So the 1/2 is part of the formula. That's a question that always comes up. The 1/2 will always be there, and then I'm multiplying the two side lengths, and then that's times the sine of the angle that's in between. So 1/2 AB sine theta. So, going from here, we have 1/2. Let's do an example now, of course. We have, let's say, again, doesn't matter what shape the triangle is in particular, but let's say we have a triangle like so. And I want to solve for the area. To do this, if I don't have base and height, I need to know first an angle measurement. Let's call this 30 degrees. And then I need to know two side lengths. Let's call this 11 and 9. So it has to be the angle in between the two sides that are given to you. That information has to be there, otherwise you can't solve this. So my area here is 1/2 times A, doesn't matter which is A, so let's say times 11, times 9, and then times sine of the angle in between, which in this case is 30 degrees. Okay. From here, this is calculator work. You are asked to write out the equation in the assignment, but again, from here, you're going to be using the calculator to be able to do this. So, using your calculator, and again, I recommend that you're using either Desmos or a quality scientific calculator. It doesn't have to be super expensive, but if you're using, let's say, one from the dollar store or that level of scientific calculator, you have to put the value of your sign first and hit enter rather than having a display window. So that's what you're looking for, a calculator where you can type into the display window and then hit enter. You're just more likely to not make an error. Right? So then I would pull up my calculator. I'm using Desmos here. Before I type anything in, you need to make sure that your calculator is in the correct mode. Just like with something like, let's say, temperature, you have different ways of measuring temperature. There's Celsius, there's Fahrenheit, there's Kelvin. There are different ways of measuring angles. So far, we've focused on degrees, but there are other ways, such as radians being the most common, other than degrees. So in Desmos, because it's a graphing calculator, if you click on the little wrench at the top right, it's going to default always to radians. So before you type anything in, you need to put it in degree mode. If you don't, you're going to get something that's way off. That's the same if you're using a scientific calculator. At the top, you're going to see something that says either DEG or RAD. You need to make sure that it's in the correct form before you start calculating. If you have specific questions about your calculator model, because there's a million, you can message me and I'll show you how to do it. So area is 1/2 times, we said 9, times 11, times sine of 30 degrees. And we get here an area of 24.75, and that is square units. If it put inches and you want to put inches squared, if it put feet, you want to put feet squared, etc. Anytime you're dealing with area, that's a two-dimensional space. And that's pretty much it. This is just calculator work, okay? Number 2. Let's throw out again just another example here. Let's say 65 degrees, and this side is 6 and this side is 7. Doesn't matter what the measurements are, right? We just need to identify the correct information and then plug it into the formula. 1/2 times 6 times 7 times sine of 65 degrees. Once we have it set up, then it's calculator work. So 1/2 times 6 times 7 times the sine of 65 degrees. We get 19 point, and then we have a decimal here. By default, for my class, I want you rounding to at least the thousandths place. So it's 3 spaces after the decimal. But pay attention to any assignment you're on. Make sure that you're following directions, because if it says round to the tenths and you round to the hundredths, it could potentially mark it wrong. So for us, that's going to be an area of 19.032. In my other classes, students had a fairly simple time with this. The only thing that sometimes throws people off is, okay, well, what if there's more than 2 sides, right? Let's say I have let's say I have a triangle like this. And I give you 28 degrees. I give you 7. I give you 20, and I give you 18. Again, it's possible that you're given more information than you need. It's also possible that if I gave you, let's say, the angle up here, call it 80 degrees, there could be more than one way to solve this problem. But if you're using the area formula, if you're using the area formula, you need to use the angle and the 2 sides that make up that angle. So in this case, if I'm given 28 degrees, then I'm using 20 and 18 because they make up the sides. So this is 1/2 times 20 times 18 times sine of 28 degrees. Plug it into the calculator. 1/2 times 20 times 18 times sine of 28 degrees. And I get 84.505. For my classes, try to do square units or units squared. If it gives you inches, give it inches squared, etc. But that's pretty much it. It's calculator work. Hopefully the setup's easy. That's all you have to do on this assignment. If you guys have any questions, please reach out to me as always. But otherwise, have a good day. I will talk to you soon. Bye.